Alright, welcome back. In this video, we're going to give you an overview of the screen system that we're actually about to start coding in the next videos. This is going to be one of those great whiteboarding videos where you can scoot away from your keyboard and just watch and learn. Now, our game, our drum game, is going to be based on the concept of multiple screens, and this is something we talked about earlier on in the intro. Now, how does our screen system work, generally speaking?
Well, the idea of the screen system is to divide our game up into, you could say, mini sub-games.
Like little tiny games that we're going to be sorting through and showing to the player.
Exactly. It's like having a class that follows roughly the pattern of the real game class, meaning you have things like an update method and things like a draw method. But the idea of separating this into a scenario where you can have multiple of these screens means that you can switch between them easily, and you also gain a good degree of focus when you're on any given screen, since you only have to code from the standpoint of one screen at a time.
Gotcha. Now, what I want to do in this video is to give you an overview of kind of where we're going with the screen system. It'll give you a really good, I hope, at least a solid grasp of how we're going to be implementing this into the system, so that as we start to lay out the fields, as we start to put in our method skeleton, you're going to kind of already know why we're doing everything we're doing. So here's just a case in point. I'm going to draw 4 hypothetical screens. I think in our final game we've actually got like about 8 screens, but we're just going to build 4 just so that I don't have to draw 8 boxes, because you can see how bad these boxes look, and I'm not sure you guys could actually survive it if I drew 8 things that look that terrible. So our first screen, we're just going to call main, okay? Because we're going to consider that to be the very first screen the player sees when they start the game up. It's going to have a little splash screen, and they can choose if they're going single player or multiplayer. It'll have some cool picture, and they're just going to be in total awe from the moment they see it. Now, the next screen is going to be a song selection screen. Now, notice I'm kind of sort of putting these together in kind of the way that you would expect the player to interact with them. You don't necessarily have to do that. It's just for this example alone. Now, after they've selected their song, they want to play the game now. They've got their drumsticks. They're ready to rock. So now it's time for the game screen. And this is the screen in which you'd actually see notes marching by, and you'd be banging on your drum, and you'd either be winning or losing. But while you're playing, you have to stop. You got to go get a drink of water, make some popcorn, go talk to your girlfriend on the phone, which you're a programmer and or a gamer, so we won't argue whether or not that's feasible. But you need to pause the game. So this will be a whole nother screen, the pause screen. So here's the thing that you're going to need to keep in mind here is, as soon as our game starts, and I hope I can do this without Photoshop flying away. If it does, I'm really sorry. All screens exist from the beginning.
And what that means is, since we'll in code be looking at screens as individual classes, all this means is that we will create every screen from the get-go. We'll have all screens in existence from the beginning.
Now, that's an important thing, because it's going to be a key factor in how we determine. Well, basically, now we need a system to determine which screen we're going to get at any given time.
Exactly, because to say that they all exist at the same time seems to imply that they all run at the same time.
Right.
And that's not the case.
That's just not true. Now, something else, too, is we also mentioned that each one of these screens, and I'll do this, these can all be considered to be mini games in their own right. These are all little tiny games unto themselves. So if we take our little drawing here and we add in, here's our primary, let's write drum game in here, because I've already got a screen named game. So we'll say this is the drum game. And this drum game already has an update in the game class. It's already got a draw, but each one of these are going to need that too. So they're going to be tying into the draw and update that's already driving our actual drum game. That's how they're going to be updating. So what we need to do from here is determine which one of these at any given time is going to be listening to update and which one's going to be listening to draw.
Exactly. What's interesting about that is it's almost like it changes responsibilities, where originally the main game class in any given game may be responsible for updating objects and drawing graphics. Mm-hmm. In this case, the full drum game hands off each of these responsibilities to whatever screen is currently on screen.
Exactly. At which point the drum game itself almost kind of functions like an engine that is turning some gears in another mini game to cause draws and updates to happen.
Right. Now the main game just manages the other games.
Exactly. Okay, so now we've got all 4 of these. They are existing. Each one is being pass, draw, and update, but you don't want them all to draw, and you don't want them all to update at the same time. So you need some way to pull each individual screen off the heap when you need it and actually get it showing. On top of that, you have the extra problem, and I'm going to draw it as a circle because the button of the back button. The back button makes everything more complicated for us because we now need to keep track of each screen as it is shown. So that while the player's playing, they're like, okay, well, I have pause now. Now I need to unpause. I got to do the finger quotes when I do that. So unpause and go back to the actual game. I hit the back button. If I'm playing and I want to go back and select a song, I want to hit the back button. So it's just like hitting back on a web browser. We've got to integrate that into our system as well. So let's just start at the very beginning. We've got all these screens. We need some way to sort through them. We're going to be doing that with a dictionary. I'm going to draw our dictionary as a block. It'll look kind of like a dictionary sitting on a shelf from the side. Not really, but kind of. We'll divide it into 4 little sections. And we have our main screen, our song selection screen, excuse me. We have our game screen, and our pause screen. Now, the reason we're using a dictionary is this is going to allow us an easy way to associate each one of these screens with a string to call it. So main could be just as simple as saying main, because that's pretty easy. Select, we can actually simplify, or the song selection screen, excuse me, could be simplified down to just select as a hypothetical. Of course, game and pause are pretty easy, but we'll do it anyway.
And you could loosely call the system a soft referencing system, where instead of using typed fields to get to each of these from inside the game, we'll actually use string names to reference them. That makes it a lot easier to code in or implement a screen that needs to invoke the pause screen before you actually write the pause screen.
So at this point, we've got all of our screens existing inside the heap. They're all being, well, if we left things as they were, they would all be being updated and drawn at the same time. But we do have the ability with our dictionary to access each one, and now we just need kind of the flip side of that. What we're going to use to control which screen is active at any given time, and at the same time give us a history of screens that we've accessed thus far, is a stack. Now, what is a stack, really generally?
In its most simplest terms, the stack we're going to be using is considered a data container.
Okay.
All it is a container of other items, but what is important is the ordering of those items. More specifically, the way in which items go into and then back out of the container.
That's right, and what Logan is referring to is that a stack is going to take items in and take items out in a specific order, which is, what is it, last in, let me write just a little more cleanly than that. Last in, first out. Now, what does that mean for us? Well, let's just kind of trace through it. We start our game up. So our drum game reaches over into our dictionary and grabs the main screen, and it's then going to dump it into the data container stack. And it'll fall all the way to the bottom. So it's now at the very bottom of the stack. There's nothing else under it. So here's our main screen. Our draw system, the actual way that we decide which screen will be drawn and which screen will be updated, will utilize this stack in a sense that it's kind of going to be just looking down from the top and seeing who's showing. So if you just picture an eye, and here's our, kind of like our program, just kind of looking down, it says, oh, currently main is on top of the stack. So main will actually receive, update, and it will receive information from draw, so that'll be updating and that'll be drawing.
Exactly. So that'll, right off the bat, facilitate the routing, if you will, the idea that the game can manage the screens and draw a specific screen.
So I'll draw an optic nerve from here that goes over to the drum game. So those two are connected. Don't ask me why I did that. It was just cool. So now we've got our main screen up, and now the game player wants to choose a song. It's time to actually get things rolling. So our drum game reaches over into the dictionary and grabs the select screen and drops that into the stack as well. Now I'm going to erase my arrow. And we now have the select screen on the stack. So now the drum game looks down on the stack and says, oh, select is actually on top of the stack, so we now no longer need to draw nor update the main screen. We want to draw and update the song selection screen.
Right, because the idea is that you look and, like you just said, look at whatever's on the top of the stack.
Exactly.
And that is the item of interest. You could say, to put it into game terminology, that would be our active screen at that point.
Exactly. So now just to keep going with the pattern, so now our drum game is time to actually play. So it grabs the game screen, it throws that onto the stack, and we do the exact same thing once again. Now we have the game screen on top. So now our program just sees the game screen. It says, all right, well, let's quit drawing and updating song selection. Now we're just going to draw and update game. And then finally, the same thing as before. We got to get up and get a drink of water, make a snack. So it's time for us to pause. So we drop the pause screen on top. And now our floating eyeball only sees the pause screen. So we quit drawing and updating game, and we start only drawing and updating pause. Now, the cool thing about doing it in this way, because our stack system works in LIFO, last in, first out, we can now, at any point the player hits the back button, player can come over and hit back, and back will start off by taking pause off the stack.
Exactly. So just following that pattern, pause was the last item put on the stack. So if we start removing items, well, then he's the first to go.
Exactly. So now the game is no longer paused. The drum game looks down and sees, all right, well, who is next on the stack? We have the game. It's just like hitting back button on a browser. Pause is gone. Now we see game. Cool. Well, we're going to quit updating and drawing pause because that's not there anymore, and we're going to start drawing and updating game. Now, let's say they hit the back button again. So they hit it again. This time, back is going to attack whoever's on top of the stack, which in this case is game. Okay? Game is taken off the stack. So the drum game looks down and now sees select. Cool. So it's time for us to quit updating and drawing the game screen and start updating and drawing song selection screen. And so with this method, you can see how we're keeping track of each screen as it is accessed and thereby making way for back button style navigation. So you can just keep hitting back and cycling through everything you've done so far.
Exactly.
Now, it's going to get a little more complicated than this because we actually have several more screens. We've got things like free play mode, we've got edit mode, we've got score screens, and all sorts of other stuff that has to be taken into account. But no matter how many screens you have, even if you had 500 different screens, which would be a really complicated game like EVE Online or something, you would still have the ability to cycle back through everywhere you have been, making it all the way back to the beginning.
Exactly. It's just that mechanism that allows us to keep a history of screens and the order in which they were viewed.
Okay, so now that we understand this, we understand that we're going to have to code up individual screens, that these screens are going to be stored into a dictionary, and we're going to use the dictionary to sort through and figure out which screen we're going to work on at any given moment. And then as we utilize each screen, it's going to be placed on top of a stack, and that stack is really just a way to keep track of who we've talked to so far. It's not like they're physically being stacked up like that in memory. It's just a way, it's almost like a list. You could just think, it's just a list of, all right, who have we accessed, and who do we need to access again? Because remember, all screens exist from the beginning. So it's not like a screen only exists when it's on the stack. It existed from the very beginning.
Exactly. It's both that name-based dictionary and the order-containing stack are actually looking at the same screens. The
Right.
main screen that the dictionary is looking at is the same main screen that may be on the stack.
Right. One of these, if you want to look at it this way, the dictionary is just a way to keep track of who's available. And the stack is just a way to keep track of who,
Like who's in use.
yeah, who's been accessed. Wow, my handwriting is terrible today. So we have who's available and who's been accessed. It's really just two ways to keep track of what we can access and what we've already taken care of. So that's the whole key behind the screen system. Now, in the next video, we're going to go ahead and lay down some of the groundwork for this. We're going to get the screen class in place. We're going to go ahead and create the necessary fields for it, and we will create the method skeleton for it. As we create the method skeleton, you're going to start seeing some methods that will already, you'll notice, they'll already start making way for the functionality we need to cause this whole thing to happen. So that's going to wrap things up for this video. Let's move on and start putting the screen class together.